Oh, can you also? Can you hear the sound on there?
Wait, stop that. Okay, now tap. I think maybe.
Is it?
If it's not working, I'll do something.
Is the sound on there? Okay, so I can click left stream.
Yeah.
Okay. Construct.
So apparently one of these can be on only. Like if. Oh.
They should both be able to. Somebody.
Hi. Can you guys hear?
No.
Not really, right?
Speak directly.
I'm hearing him, but not you.
Yeah, only one can be on at a time. Like the other one doesn't. Well, it's kind of working.
It's just quiet. Here, let's just turn up the volume.
But if you turn yours off, then mine works perfectly. I think it's interfering. Oh, it seems to be working fine now.
Yeah, David, where's your mic?
Right.
Huh?
It's right here, here. It's coming through.
Okay.
And that's the feedback. Huh? I don't know if it's
You know what it is? You know what? It's not channeled, but it's positioned. See, it's filtering out. It's trying to prevent a feedback loop. So if I walk close to the speaker, it's going to shut off the audio.
Yeah.
So so we need to disable the speaker.
But
Here.
it's.
Check this out. We're gonna move the balance.
But if I turn mine off, then it's perfectly fine. Mine is off right now.
I think. Okay, I'll just shut up.
Okay, so now we have gotten some technical issues done. Did you check that the live stream is actually streaming on the landing page? Or possibly. Okay, so I will be doing part of the tutorial today, and then Peter will also add in some extra stuff that I forget to mention, and he will also be taking care of the second part where you guys will actually be working on the tutorial tasks. So today we're going to work on lecture 2 tutorial. So if you haven't pulled the latest version of the Scholar Class repo recently, as in really recently, in the past maybe half an hour, please do that again. So we're always constantly updating our material, so like make sure pretty much before class every time just update it.
How do we do it for the report?
I'm sorry?
Report, so how do we do it?
If you look on GitHub, you'll see it'll say upstream repository has changes. So you're going to do a merge from our repository into your repository. Let's see.
Okay, so I guess I'll give everyone a few seconds to make sure everyone has done that. If you have any questions, ask us. We'll come around and help. Everyone good? Any issues with that? Okay, so while, in case I'm still taking care of stuff, another thing that I sent out in the email to you guys, I'm not sure if everyone has seen it, is that starting from tutorial 4, so not this one and not next week's one, the one afterwards, we're actually going to be auto-grading your tutorials. So in order to do that, we'll explain in more detail in either next week or on Gitter, but in order to do that, first thing is you have to have forked the Scala class repo, like have your own fork copy. So yeah, so today it's fine if you're still working on just like the direct repo and not a fork, but in the future, know that you will have to do that. Okay, so everyone good with the updates?
No.
Yes. So the, hold on.
The average 2 and 6. Refresh should show up.
I mean the public one.
Oh, okay. Good, it's myself.
Okay, so I guess I'll start talking a little bit. So the big theme of what we're going over today is folding over lists or collections of that type. So we're in lecture 2 tutorial folding, and our first few parts is going to be a lot of talking and discussion before we get on to you guys actually working on the tasks in your code. So to start with, we want to look at this folding.scala file here. Oops. This guy. And so in your terminal, if you could go to this path here, and in that path, run this command. So, oh, that was not supposed to happen. Run Scala, folding.scala. If with the 2.11 it doesn't work for you, then just run Scala without the 2.11. So once you're in here, do Scala -I and then folding.scala. And so this will get us into the Scala console. You can ignore warnings for now. And then the first thing we want to look at today is this function. But in order to do that, the methods that we're going to look at exist in the object folding. So we're going to import it first. So import folding. And then enter this method here. Okay, so when you do this the first time, it's actually going to show you a bunch of stuff which is actually not what we want to see right now. If I run this command again, this one line is actually what we're trying to get out of this method. Now the reason for that whole bunch of other stuff is because that within that object folding, there are some print statements. If you go through the source code yourself, you'll see some print statements that outputs these lines. And because when you load this, it's lazily evaluated, as in they won't be loaded until you actually try to do something with it. So when we tried to call this method, that object was actually loaded, and then the print statements got ran. And so those print statements right now that you see aren't actually what we want to do. So for now, ignore those. What we actually want to see is this bottom line over here. Okay. So once you run that myToString method on a list, what you see is a string representation of what that list, the linked list structure actually looks like. So is everyone okay getting this running on their terminal? Good? Okay. So going back here, so you see in the README, it talks about what that myToString method actually does. It's really just to print out the structure of the list. Now there's two ways you can look at the list. One is just pretty much what you look at a list as like. It's just 1, 2, 3, 4, like a sequence of things. But in reality, this list here is a linked list, which is nested and looks more like this. So the pretty printer depends on what you define pretty as, either easy to read or what the actual structure is. So right now it's printing out the actual structure. So if you look at the source code, here is this big enough? I'll make it bigger. Here's that method. So, not really.
Yeah, do you want to move the
I'm trying to, I want to shift the balance over to that speaker entirely, I can't figure it out.
There's still some feedback.
Okay, so hopefully you guys have actually read all of the chapters that we've assigned for the past 2 weeks, and if you have, you should have come across this, what's shown here, which is pattern matching, and this allows you to find the pattern out of here. Our input argument is a list type. So a list type can either be nil, which you have an empty list, or you have a head. This operator syntax is the name for it is cons, head, cons, tails, which means you have the first element and the rest of the list. So you pattern match on either of these situations. So what my toString function does is that if you have an empty list, it just prints out foo. And then if you have an actual list with content in there, it will do print cons, which is what you saw on when it printed out stuff. There's cons here. And then prints out the head, prints out a comma, and then it will recursively call this function and does the same thing on the rest of the list, which is the tail. And so you get this recursive thing where you have a cons and another cons wrapped in it, and another one until you get to the last one. And so this is the structure of the linked list you're seeing. So there's several functions that could do something similar to this, and it would be a complete pain if you have to write this structure of code every time for each function. So an abstract way of representing this, as you might have seen in chapter 5, is to use what's called a fold type of function. So here we're going to talk about fold right first. So here we have an implementation of fold right. It's also in the source code a bit lower down. So if you look at this structure, this case pattern matching structure, it's pretty much identical to what we were just looking at. You have the empty list case, you do something with it. You have the case where your list actually contains a head, cons, the rest of the list. And then you apply whatever function you want to it, so you could just do nothing with it if you want. And then recursively go into the rest again. Okay. So this is basically what a fold right would do. If you see here, here's our my toString again. And so now that we've abstracted out this pattern with the fold right, we can replace our my toString method with a my toString number 2 using this fold right. Okay, so here, one more thing before we go ahead is that if you notice, here are the type parameters that hopefully you should be familiar with because we talked about them a bit in the last lecture, the last tutorial. So these are just representing types that you haven't specifically defined for this specific function. It can be anything that you want to input here, but this A type has to match whatever is in your list, and then that function has to take the A type as well. So these are just type parameters that are, right now are generic. So to implement our my toString 2, we're going to start by implementing it for strings. So here, our my toString 2 is again going to take in a list, and it's a list of strings. And to use fold right, we have both type parameters being strings. Here's the input list. And this here is where we're going to look more closely at that case where it went to the empty list case. So going back to fold right, if you look at this here, you'll notice that when it's case nil, you get the return result of z. And z is that second argument here, which is basically the base case. Like, what would you do when you reach the end of the list? Or what would you do if you just came in with an empty list? Like, it's the base case what you would do. And then any other case would go over here. And so going back to my toString function here, this second parameter list here is a function that you actually want to apply to your arguments that you're recursively going over in your list. And so this, there's two arguments to this function. The first one is the next string that you encounter as you recurse over the list. And then the second argument here is what you've accumulated so far. And so you can put any type of function here that you want. You could concatenate your strings. You could, if it was an int, you could add those ints, that kind of stuff. And in order to combine these two inputs that you're recursing over into one, and in the end, you'll get this final one accumulation. And so if we wanted to print out the accumulating string for fold right, it would look more like this guy over here. You would start with, like, you would recursively get the end of the empty string first, like the very end of it. Oh, well, here is what the whole thing would look like, right? And because you're recursively going to the end of the list, you would actually start with getting to the empty part first, which is the nil. So if you printed out each step, you would get the nil back first. You will return that to the previous place where you recursed into it and gets the next part, which is this. And then recursively, you would get more and more of the list until you finish this whole thing.
We can take a break and then we'll all do this console.
Okay, so do you guys just want to try trying the my2string and the my2string2 functions in your console and see what you get?
So this is full depth, so we're still in full depth.
Okay.
Is it this one or my2?
Not yet.
That's I was in the section. Great. Okay, so here's full depth, which is not tail recursive. And two.
Okay, so going back to my toString2, I said that that function in fold right can be anything you define, right? It can be concatenation of strings, it can be addition of ints if you're having ints. So we haven't actually defined that yet for our my2string. So a function that would be what we want in this case is to print out the cons, the brackets, and all of those. A function could look like this line here. You start with the cons. You want whatever is the next thing that is you're recursing over in your list, a comma, the accumulating part, and then ending it. And so this would be an anonymous function that we could use for fold right in order to implement our my2string2. Equivalently, you can also write it as an actual function with a name, so that's the foo over here. And the last thing that we need for for fold right is that base case, right? What do we do when we get to end of the list? So this base case here would basically, we want to print nil, signifying the end of the list, as you've probably already seen from all the printouts. So in total, our my2string2 would look like this. You have the fold right function. You have the input list, which the my2string2 function also gets. The base case, when you get to the end of list, is a nil. And then the function that fold right uses to combine everything in your list is an anonymous function that we just talked about. Or you could give it a name and just put the function in here. Okay, so here is my2string2 in action with a list of string 1, 2, 3, 4, 5s. Okay. Note that we explicitly put the 1, 2, 3, 4, 5 in quotes, and there are strings now because we only define our my2string to function to work with string types. And so that is the next thing we're going to do, is we're going to convert our my2string2 so that it is more useful to be used for any type. So we're going to be folding over generic here. Okay, so if you recall, the first my2string function we had actually was not specific in its type. It had this type parameter here with A, and it was doing the pattern matching by itself without the fold right, but it had that type parameter there. So that's the sort of thing we want for our my2string2. So we are going to replace the fold right and specifying string and string with a fold right, but leaving one of the types as a generic. And that's where this A is coming in here. And so our foo function that does the string combining thing, we have a foo2 now, and this will also have a generic type A. And because mostly everything, well, it says right here, and has a link to. Every type in Scala has a string representation, and it will automatically do that string conversion when you need to do string, when you try to do string actions on it. So a case like this, where you're obviously trying to concatenate strings, it will try to convert, there will be an implicit conversion of whatever type this head is to a string. It will always have that conversion available. And so we'll do that. And so our my2string3 here actually doesn't look that much different from my2string2. You still have the list, the base case, the function. All that's different is now we can generalize over this parameter type here. So problem solved. So we have my2string3 with the list of, you can have a number. Everyone good? Okay. So hopefully you guys have been trying that in the REPL. So no questions about that?
If you import and try, you're going to get a lot of interesting lazy output.
I'm sorry?
If you import the existing folding object that's in the folding Scala, and then you try to use it, there's a ton of lazy variables being defined that are going to possibly confuse folks. If you just type it directly into the REPL, you'll have a good experience.
Yeah, so that will only happen the first time though. So like the first time I ran this, I got that bunch of stuff as well.
Right.
So don't be scared by this. This is only because the objects that we imported, the import folding, the stuff in it is lazily evaluated, and so it only printed out what it was supposed to print when I did something. So if I run this again and again, that will never happen again.
If you're editing your file and make a syntax error and reload it, you might be very surprised.
When you reload, this whole thing starts again, so.
Right.
Okay, we'll move on then. So part 2, we're going to discuss fold right versus fold left. So I've only been talking about fold right, and there is another fold left. So I actually want to, no I don't want, I'll go through the code. So the fold right function looks like this block over here. You have, in the case where you do have something in your list, you apply your function to the head of the list, this x here, which is the head, and then xs is the rest of the list, the tail, and you recurse fold right onto the second part. And so what this does is that you actually will have to go into the deepest layer of your list before coming all the way back out in order to finish your function. So it's not tail recursion. And so we try to let you see the stack trace with this fold right printer here. This guy, what this basically does is the same fold right, except that it has prints things at each step, telling you what's the current input, what's the current output, to tell you what layer of stack we are currently in. And so if you try to run the we just also define the my2string3 printer based on this printer here, so we can now see what it does. So we're going to try that. Oh, not found. Did I not import something? Sorry, give us a second. The MyToString printer has been misplaced somewhere.
We cut and paste it into the record.
Is this my two-string free printer or which?
Yes.
Okay. I think Chris had me remove that from the code, so you'll probably fix that too.
Oh.
Okay. Here we go up to my two-string free. Sorry.
Oh, it's just my phone right here.
Okay. Try one of those two. Probably be done. So let's go back to this. Oh, two problems. Let's see. Sorry, I really lost which section are you in? This one? Okay. I see. Okay. Copy. Insert paste mode. You could. Okay. And then do yes. And then
Oh, okay, good.
Okay,
Sorry
so
about that.
then do that paste mode.
Okay, so we accidentally took out the MyToString 3 printer from the source code, but it's a very short function. So we're going to ask you guys to actually input this function yourself in the REPL. Hopefully you're still in there. So if you, could you throw that on Gitter?
Yes.
Oh, just this guy. The printer's in there.
Okay.
So Peter is currently in the process of putting the MyToString 3 printer into the Gitter channel. And so while he's doing that, one extra thing which is good to know in the Scala console is that when you want to do multi-line inputs, if you just type directly in here and you click the enter, it might not know that you want to continue to the next line unless it is expecting something else like the end of the brackets or something like that. So a good mode to go in is to, oh, you might not, I hope you guys can see, colon, paste. And so this would enter paste mode. And so if you're copying and pasting something from somewhere else, like the thing that's on Gitter right now, the function, you could just paste it into here. And then I think it always needs an empty line, so we're going to do that. And then do Control V, and then you should have your function in there now. And so now that you actually have the MyToString 3 printer, let's go back and try that example. So here's our MyToString 3 printer with our list 1, 2, 3, 4, and it will output all of this stuff, which shows you basically the stack trace of what is going on when you're going through that list with full write. And so you see the main point here is that it goes in, that's the input lines, from the whole list gets shorter as it goes in deeper and deeper and deeper until it gets to the end of the list. So you have this last one here, and then it has to go back out now. So output nil, the cons with the nil, the cons with another cons, and then so on. So it has to go into the deepest layer and then come back out. So that was the purpose of this printer here, to show you that. Okay, so this diagram over here kind of shows you what that fold right is doing. Is that if you have a list of 1, 2, 3, 4, remember this is just, oh, this is not really constant. Okay, some operator, this is connecting the whole list. You have 1, 2, 3, 5, and you apply some function on it with fold right. and Z is your base case here, this is what the tree is looking like. You go in here, the rest of it is another subtree here. Then it goes into another one, and another one, and another one until you finally get to the end. Okay. Now this is going to be in contrast to the other function we're going to talk about, which is fold left. So fold left has its own diagram here too. So again, we have our 1, 2, 3, 4, 5, but you see the tree is in the opposite direction. You instead start with the base case here, you combine it with 1, this is done. You combine it with the next one, at each stage it gets done. And so, so basically what it says here is that fold left will not use up memory on each of the stacks. So with me, I have fold right because you have that whole stack thing. So you have a super, super long list, you're going to get stack overflows. Fold left, that's not going to happen. It is not going to be, the memory usage is not going to be proportional to the size of the list. However, because it does this in like reverse, your results are actually going to be in reverse. So if you're doing something that is commutative, like if you're just adding 2 numbers over your list, then that's totally fine. I mean, 1 plus 2 is the same as 2 plus 1. But if you're concatenating strings, the order is going to matter, right? So that's where you're going to have a problem with fold left, which is fixable, with some penalty as well, which we'll talk about. So this is the main difference between fold right and fold left. So here is a comparison of what the code actually looks different. So remember fold right, the tail has to like recursively go into fold right before this whole function can be applied. For fold left, the function gets applied for the head and the base case while the fold, and then the rest of the recursion continues. So it's a tail recursion. And so in Scala, you get this nice tag here that tags this as a tail recursive. And so if your function is actually not tail recursive and you try to put a tag on it, it will throw an error and tell you. Okay, so in the same way, we also made a fold left printer for you to see the stack trace. And so I wonder if my 2-string-4 printer is in there. Is it? We will try and see. It is not? Okay.
Helper laziness.
So Peter is going to look at where we're going to find the printer number 4. But before we do that, I also want to point out one more thing, is that we talk about how the fold left is tail recursive, right? But our implementation of the fold left printer here is actually not going to be tail recursive, even though it's an implementation of fold left with prints, right? But the definition of a function being a tail recursive is that it has to finish the last thing, whatever it's doing, before it goes on to the next recursion. And the very fact that we are trying to print things, like print line, all of that, after we recurse, makes it actually not tail recursive. Okay, so fold left itself is tail recursive, but this guy here is just so we can see the stack trace. It's not very tail recursive. Okay, so luckily, even though we don't have the actual function, we do have outputs here on the markdown that we can see directly. So if we looked at the stack trace of a fold left function, you actually see that you get this sort of output.
What does the annotation do?
I'm sorry?
When annotating it, the tail recursive annotation, what does it actually do?
One thing that it's able to provide is that if your function is actually not tail recursive, it will throw an error. And I think does it optimize things?
It's mostly just about enforcement.
Yeah, it's mostly just.
It does actually optimize it. So So if you do recursion, it'll do some optimizations over that too.
Oh, okay, so our printer number 4 is now on Gitter. So if you guys want to try that out. So I'll give you guys a few seconds to do that. Everyone get it working? I will take that as a yes. Okay, so I will move on a bit. So one thing I mentioned earlier is that because fold left does this in the opposite order of fold right, if your function is not commutative, you will see that everything is in reverse. So remember our list should have really looked like this, where you have a concept of 1, the tail is a concept of 2, and the tail blah blah blah. But when we did it with fold left, what you actually get is everything backwards. 4, 3, 2, 1. Okay. So one way, actually I think the only way right now, is if we wanted to have the same functionality, you could reverse your list before you do your fold. And so we're going to try to do that by trying to implement fold right with fold left. Okay, so this little example here is just if you have a sum, which is totally commutative. If you fold right, then you fold left, you get the exact same answer, you'll never notice the difference. But if you have the string methods, it will be different. Oh, and here is a nice comparison showing the two. Your list is now on the opposite end. And so if you want your list to not be reversed, but still use fold left, because it's tail recursive, it's you don't get stack overflow issues or memory, a lot of memory usage, it's good to use fold left. And if you want the same results in the order that it went in, you could reverse your list. So instead of list 1, 2, 3, 4, you input list 4, 3, 2, 1. And so that is the way we're going to try to implement fold right via fold left. So basically, the fold right is just going to feed the list to a fold left, but reverse it first. Okay. Now this will absolutely work, definitely, but if you reverse a list, there will be the cost of reversing a list. So this is really just showing how you could do it.
How I think it's actually implemented in Scala.
Sorry?
It actually does this in Scala now. It used to not, so you get recursive crashes, but now it does in fact call fold left and then reverse.
Yeah, I think so. I read that somewhere.
Yeah. It's cheaper.
So I think the take-home thing here is that if your function is commutative, use fold left, because it is more efficient. You don't have to incur the cost of reversing your list, blah, blah, blah. So fold left is good. Peter, did you have anything to ask that?
I would just mention part about primitive and non-primitive combinators. So the fold left, the fold right via fold left is built on top of fold right. Well, it's built on top of fold left.
Okay, so combinators here, we will be talking about more on primitive combinators and what they're defined as when we get to monads and functors and all of those. But basically, the folds here are a primitive combinator. It's one of the basic things that you can do to go over a collection, like a list over here. So those are the primitive ones. But our fold right via fold left here, because we implemented this function on top of fold left, it's based on it, this is no longer a primitive combinator. And this is a nice thing to know as we go on to talking about monads and stuff. So just keep this in mind. It's not super, super important right now. So we are on to part 3, and you're actually going to get to do stuff yourself. The fold right and fold left that we have here, okay, I can't find the implementation right now, but we've been using our own implementation of fold right and fold left. And, oh, here. So here's the signature of our fold right and fold left. So the ones that we defined ourselves had the list and the base case in the parameter list, and then the function as well that you want to apply. Scala has its own defined fold right and fold left, because obviously this is a very common and useful thing to have. So Scala has this defined already, so the list type has the fold right and fold left methods defined on it. So from now on, as we go on to you guys working on the actual task, we're going to use the Scala defined fold right and fold left. So the signature looks a little different. It's that these methods are defined for the class list, the type of list. And so say I have a list A. I can just go A.foldRight, my base case here in the first parameter list, and that function, the combining function in the second parameter list. So these are the fold right and fold left that we're going to use. So the first thing you guys can work on is implementing an average. Oh, sorry, I lied. You're not working on it. The dance is right here. So I will talk about it first. Implementing the average, there's 2 parts we want to walk over for the list. One is you want to sum everything up, and the one is you want to be counting how many elements you have. Right? Obviously, there's also a list.length kind of method, but we're going to stick with folds right now. Okay. So how this average function is implementing here is that you do it in 2 steps. You have a list.foldLeft. The base case is just 0 because we want to sum up everything. And then here, this, have you talked about the underscore?
No.
Okay, so this is kind of, I guess it's syntactic sugar for Scala. So instead of writing your parameters A and B going to some outputs, A plus B, you can just do this. So Scala will know that this is the first incoming argument, and this is the second incoming argument.
It's an alternative way of making an anonymous function more concisely.
Yeah, it's just pretty and clean. Okay, so this top one in the numerator is just summing everything, and this second one is counting. Oh, probably one other thing that I should point out. Oh, actually, never mind, sorry. I'll go ahead. So the counting here, the function is that you have your current accumulating counts, the next one, and you don't really need the next number, right? All you want to do is that increment that count. So that's what this function does, count plus 1. And so here is what you would explicitly write out if you were not trying to use this underscore syntax here. You would explicitly write out, and you probably don't really need the types here. Scala is probably able to infer that, but it's good to be clear as well. Okay, so this actually has one problem, that it will throw an exception if you have an empty list, because you defined your folds with a base case of 0. So if you encounter an empty list, the answer you're going to get as you fold over them is going to be 0. And 0 divided by 0 is going to be an exception. So one of the later tasks, we're going to actually ask you to try to take care of that. Okay. So now you're actually going to work on this. So task 3 is average 2. So the first average implementation did twofold. So you're going over the list twice, which is completely inefficient. You could just do it once and get the same results. So that's what you're going to work on here. And I think Peter will talk more about that.
Super. There's 3 versions of average in this tutorial, and you'll see how they improve by version 3. Thank you, Janie. Good job. Cool. I'll just put my laptop over there.
Okay.
Oh,
Too late.
okay. Besides, you don't have Dvorak set up. Thank you. Thanks. Yes, that's a great point. Did you share your, is that on? Great, okay. Let me briefly show you guys the real implementation of fold left and fold right in the Scala standard library, or list. And our implementation is supposed to copy this one. We need to point out why the arguments to this anonymous function op here are reversed. There's 2 reasons for that. One comes later when you start to work with lazy lists or streams. In an anonymous function in Scala, you can only have a lazy parameter to an anonymous function has to be the second or next parameter after that. So the lazy syntax is to have an arrow here ahead of the A. That's important later for streams. There's also a reason that I think is kind of historical in how they copied fold left and fold right from Haskell. Because in Haskell, you wouldn't have a function that takes in 2 arguments. You would have a curried function. And I believe there's some important reason there why in Haskell the function that you pass into fold left has the B in front of the A. So that's the question. Class. So your first task is 3A here. You might know of a mathematical function for calculating a cumulative moving average, where, or like a rolling average. That comes later in the tutorial, so if you know that function, don't use it yet. We are still calculating the actual average after already completing the fold. later you're going to get to do that a rolling average, which is pretty cool. So use the answer that we gave you for calculating the average with two folds to make the same thing happen in one fold. And take a close look at what the B type is. That's fine. Okay, so the intuition is that it's wasteful to use more than one fold. If you can, put these two operations into a single pass through the list, you're going to save some computing time. So re-implement this function here. Right here. So I give you this much, and you're going to complete the not the implementation of fold left, but the usage of fold left. So here's this version average, def average, 2 calls to fold left. You're going to be able to do the same thing with a single call to fold left. But it's not going to calculate a moving average. So it's going to, well, I'll let you guess what the meanings of these two types are. It's going to be a little bit more than something. It's going to be 2 folds. Yeah. Exactly. Yeah. And you're going to do the same thing in a single fold, single call to fold left. So the intuition is, and this is important for streaming later, that doing 2 passes through the same list is a little bit wasteful. Pack the same work into a single pass through the list. And be sure you know what the significance is of these 2 types in a tuple. Hey, thanks, Jake.
Alright, so you don't even need that Scala one anymore. Like that's the master branch, so kill that clone and just clone the fork that you have now. And that is that. You said now that I'm no.
Thank you, Jake. How's it going? Yeah, combine it into a wonderful. Okay. Great. 1 pass to the list. Sweet. It's also worth an explanation why there's a case statement there. This is not the same case statement as used in pattern matching. It is the same case statement, but there's a different usage. You wouldn't get to extract the values of this tuple if not for the case statement. So this is one extra little layer of complexity here on how you write an anonymous function in Scala. Here's the fold left that we give you over here. We have an anonymous function which has two arguments. It takes an account and the next. And Scala is able to infer what the type of count is and what the type of next is. Well, you see almost the same syntax here. Looks like a tuple. There's a difference though. This is actually not a tuple. This is the head of an anonymous function. It's the arguments to an anonymous function. This is a tuple. So if not for the case statement, your anonymous function would look like this. And then you would have to go ahead and extract the double and the int from that tuple. Now that the anonymous function has more than one line in the body, I need to put in parentheses. That usage of the case statement, I believe, is taken from the partial function. So you see here in a partial function, you have a usage of case that is not paired with a match statement.
So you just kind of get a different idea. Yeah. So I mean, you should be able to.
Another problem-solving technique for these problems is to plug in the type just in the signature here without even doing an implementation and just see if it is kind of intuitive. So the next problem is contains. You're going to use a fold left or a fold right to see if a certain element exists in a list. And you know that the output of contains is a Boolean. So you have to figure out what D should be. And thinking about the types before you even think about the values or the function op, which is a value, is helpful. So I'm going to walk around and see if everyone's got contains. It contains? Let's see. Gotcha. Okay, okay. Did you import the folding object? Dot underscore. So that you've imported the object, but it hasn't bought you anything because it's still the same like scope. So if you want to pull all the members out of the object, then it would be try. Wait, show me import. Ignore that anyway. Yeah. Folding. Dot underscore. Great. Great. Now you should try calling the first implementation of average, which is the one that I give you. Yep. And you're going to see this lazy output of all the things, but it's only going to happen once, so do great. Good. Now you can proceed. Have you got it contains? Cool. Super. Yep. Yep. What about contains? It's the next task. All right. Okay, that's cool. 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 All right. Let's see here. Where is it failing? Okay, so basically you're misusing the anonymous function syntax. So what I like to do in that situation is don't go for the wildcards right off the bat, because do it more explicitly. There's two versions of anonymous functions in the README, so do it the more explicit way first. And the other problem here is that it looks like some combination too, but just you get the signature of the anonymous function right before you actually do an implementation. See, underscore dot plus is, you know, once you're adding things together, that's on the right-hand side of the arrow, the anonymous functions. Okay. Cool. Thank you, Carl. Hey. What is the compiler error? Okay, so well, here I'll show you. So pull the getter, please. Do the getter. Great. Okay, now look at that link there. So I'll tell you one thing is you're jumping ahead if you're using that anonymous function syntax, because you're more likely to make a mistake with it. But the types of the arguments have to match up with this op. So what you've done is you've created a function that takes in a Boolean and a Boolean, where you need a function that takes in a Boolean and an A. Yeah, yeah. But first of all, you're going to be less error prone if you use the explicit anonymous function syntax. Yeah, cool. Hey.
It's true. if it's false, then it would already be found.
Yep. Yep. Yeah, just test it and then you're good to go. Yeah, great. And what does it do if the list is empty?
Yeah, so it's, I mean, my initial value
Is a false, right? So good, great, wonderful. Okay. Hey, Jake.
Close, but I know. Okay, so I know I basically just false.
Cool.
I know that I have a list and item, and I know I need to check the specific. As I go through this, what I'm saying is this thing the item?
You're close, but you've made one intuitive mistake here, which is that you don't have a list and an item. So be sure that you know what A is. By the way, A is defined up here. A is defined up here. Okay. So all of these members, you might be wondering, if I look at fold left here, where's the A coming from? Right? A is this generic type. It's all the way up at the top. Okay. So this fold left method exists inside an instance of this class list. So by the time you have access to this fold left method, A has already been made concrete. But for any list of concrete A's, whether it's a list of strings, a list of doubles, or a list of ints, then you can use fold left for any type B. So B is not fixed. It's kind of cool. So that's, if A were unfixed here, the A would be declared right here. It would be A comma B.
Okay, wait, so then is it more appropriate to think of this? Maybe this is probably, I have maybe I'm confused, but this is something like this. That I have like 1 and 2. One is compared.
Not quite. It's let's see. So you got this type right, I think. Okay. What's the meaning of this type to you? I mean, does it have any correspondence really to the input type of the list? So you have a list of doubles.
Yeah.
And this is a sum and this is a count.
Yeah, so this is well, the int is like the head and double is like
Not quite. No. This is a count. No, this is the sum of all the items in the list, and this is the count of all the items in the list. So this could be anything. It could be a string. It doesn't have to have any correspondence with the type of list is. So it's not true that this is at all related to. Yeah.
All right.
Oh wait, let's see.
Keep wrestling with it.
Wait. No, I'm sorry. No, you're right. This is one element coming out of the list.
Yeah, and that's been made concrete, right? And so then I want to say is B that.
Yeah, I was talking about B. I was all goofed up. Yeah, so this is going to be one element of A, and you get to decide what B is, but you've made a mistake, which is the type of B. So you should figure out what the type B needs to be. And one helpful... No, you don't, but it's helpful because usually it'll infer it. But and then this type will have to line up with that type. And it can be helpful to just look at this and figure out what that type B should be before you implement any of these.
When you extract generic, makes everything come up.
Yeah, and you know why this is called a type parameter? So these are called value parameters. And some people call this like a generic variable or something, but it's like an argument with the type. So, yep. But it's not required to pass it in all the time because it can infer it some of the time, but you can always do it explicitly. Hey, yeah. Yep. Great, yeah. Good. That's fine, yeah. Yeah. Yep. Whoops. I shouldn't have closed it. It's okay. Carl, can I get you on the same page with SBT? Because I want to get you into the console so that you can use the codes. So go back to the folder we just did. The CD Scala class. You know about auto-completion? It just type tab in so what you can do is you just type the first few letters, and so long as there is not another option so that it would be ambiguous, it will fill in the rest of the, yeah, kind of cool. Now type in SBT. Yeah, great. Okay, so now you're going to let this download all the dependencies, and then you will go into the tutorial subproject, and then into the Scala console. So it's project tutorial, and then after that console. And then you'll be. Let me, can I type it up for you in a different, while this is working? With a notepad or something, great. So type in project, space, tutorial, TUT. ORIAM. Super. And the next command after that one is completed will be console. CONSOL. Super. That's it. And then you will be in the Scala REPL. And just let me know when you get there. Thanks, Carl. Hey, how's it going? That's true. Yep. Now, one mistake here, one confusing thing is that we're no longer using the implementation of fold left that is up here. You're using the one that's built into the Scala collections. So for that reason, we don't have to pass in the list because the list is over here. So, and you can, I put a link into the Scala doc for that method in the channel. Let's see. I see. Okay. No, it is current. Well, let's see.
Well, but it's one of the I was really looking to apply to the partial function.
We actually saw this last week with the Gaussian. You remember how you could build a Gaussian. It took 3 parameters, but they were separated into 2 different groups. So in the first group, we had these 2 parameters for shaping the Gaussian curve. And then in the second group, the third parameter, we passed in the, I think it was the horizontal position. Was it? Or it was just the input value for the Gaussian distribution. Oh, sorry. Yeah. I'll fix that. But let's see. I would. That's fine. That's right. Well, let's see. This is a type parameter, and they call it that because you can put it in explicitly as a parameter if you choose to or have to. And this is a value parameter. This is also a value parameter.
So whatever I choose here, all the B will have
whatever you choose in the brackets, yeah, the B over here will be set by that, including the output type. So this notation from here to here, this is the type of a function. So it is a function that takes in 2 arguments and returns a B.
So you must pass a function.
Exactly. Yeah, exactly. That's correct. Yeah. So this is how you would write a function that accepts another function that doesn't have it. Yeah. Except typically a callback, and you'll see this in Scala too. The return type would be a unit for a side effect. So
it's like an operator.
Yep. Well, this one does return value, but in JavaScript or something, typically the callback would just perform a side effect, it would like do some asynchronous, printing or something. Exactly. So, but we don't like side effects in Scala. We don't like functions where their output type is clear. So,
So that's that function getting one section from the current function. This is so whatever.
let's see. I think it's well. First, it's not a cumulative moving average. That comes later. If you describe this as your average, then you were talking about. Yeah, you're right. So you're jumping on to the next to version 3, which is average 3.
So this is
Yeah.
so this is going to be the type. So it's a tuple.
This is the B. A B. B is a tuple or double L. Yep.
So now you can check it. So then what is going to be the type of tuple? Inside that tuple will be double for project.
Exactly. Yeah.
And inside here,
It started.
the parameter.
It would be if you go the 0 case, yeah. So show me fold left in the Scala standard library. There's a link to it in the GitHub, please.
Yeah, this is what.
Oh, great. Yeah. So here's fold left. So here's that starting tuple. And there's a bit of a misnomer here, which is that I'm saying the average of an empty list is 0, which is not true. But yeah, the starting value would be a sum of 0 and a count of 0. Yeah, so it's
So B is going to be tuple.
Exactly.
That's what we're going to define.
Exactly.
And now we have a function that is going to return.
So B is, you're right, B is a tuple here. And then this is the next value coming off of the input list.
I thought it would be.
Not quite. So it is confusing. We have a tuple. B is the tuple. And this, in fact, is not actually a tuple. This is just the syntax for an anonymous function. So
And the count.
exactly. Inside B, you have the sum and count, and then in here is the next value of the input list. Exactly. So your function. So now that is the significance. Can you read me, please? For the whole tutorial. Yeah. Great. Thanks. Now, that is the significance of this blip up here about accumulations. So what I meant by that. No worries. Okay. Okay. So here, this is a different version of fold right because we're passing in the list itself.
This is the types, so I pass the string.
Well, this is okay. So this is not this implementation of fold right is not inside the instance. Okay. Okay. So this is almost the same. Here's the Z.
So cumulative.
Yeah. Sure.
I'm going to look at this. I'm reading it like I'm reading that.
Okay.
This is a type, is that right?
That is correct. You're creating a generic type, and the difference between okay, these methods are built into an instance of the list class.
Yeah.
Okay, so that's the reason why this version of fold left only has one type method.
Oh, we have these defined. Okay.
Exactly, A and B. Okay, so A is fixed up here, whereas this one is more analogous to a static method in Java or something like that. So I supply the list, the A type here and the B type here,
Okay.
and this does not exist inside. I cannot do, if I have a list 1, 2, 3, I cannot do list 1, 2, 3 dot fold right, but this one, because this exists outside of that. So I would do fold right, and then I would pass in list 1, 2, 3.
Oh, yeah.
Okay, so, and typically in Scala tutorials, you'll see this version first, because it's easier for people to think about, because to think about like a method that exists inside of an instance of a class is kind of confusing. And the other nice thing about this is that all your types are right in front of you, whereas in this one, the A is way up here, and you know, it's not exactly apparent where it's coming from. So,
So I'm sorry, so you're
No, it's
going
fine.
in here, you're trying to.
oh, sure, sure. Okay, so this one is very similar. This is fold right and fold left, but otherwise it's very similar to
The parameters of this, and then the other parameters of this.
oh, well, so you have several value parameters. You have yeah, the list that you're going to fold over, and here's your starting value, the base case, or the zero value.
Oh, that's why it's
Z, the base case.
Oh.
Now, you get to pass in a function that is going to handle whatever comes in off of this list. This is the accumulation. This is the one so far. And then this is going to be the next one. So if I...
the end result of that function.
yeah, so if I want to, say, okay, I have a list of strings, and I want to, which is passed into a list of strings, and I want to concatenate them into a single string.
Yeah.
Okay, so this would be, what do you think this would be? If I want to concatenate, no, not quite. It's not the first element. It's not the first element of this list. It could be whatever you want. It's just appropriate for the situation.
Just to start that.
Yep, just to start out. What do you think would be an appropriate value for you? Exactly. Empty string. Perfect. Okay, this is going to be the next element coming off of this list. This is going to be the string concatenated so far.
Which is the empty one.
On the first iteration, yeah. But eventually, if I have a list of 3 strings of foo, bar, and baz,
Yeah.
at first this is going to be empty, and then on the next round it's going to be foo, and then on the next one it's going to be foo, bar, and then on the next one after that it's going to be... this is the one so far, and then you have an opportunity here to implement a function that's going to combine this one and this one somehow to produce this value. So this would be over here to the right side of the arrow.
This is not
would be where you
concatenate.
concatenate.
The operator.
Exactly.
Function operator.
Yeah, the other critical point here is that if I have foo, bar, and baz, I want to concatenate them together. I'm not concatenating them at the same time. I mean, it's like a one-liner style whatever. I do foo plus bar plus baz. But instead, I'm doing foo plus bar, and then foo bar plus baz.
So I understand,
Yeah.
the null string, null, food, and bar.
Well, null would already disappear. Yeah, so.
But it's still really considered part of that string.
It's still in there, but it's not going to add null for a second time.
Yeah, it's not
yeah.
gonna-
Does that help?
Yeah, that was.
Cool. And then they get more abstract. So instead of concatenating, I mean, this doesn't have to be the same type as the input.
Do you guys want people to define this function?
Uh,
Or do you want to-
let's see. Well, it depends on what you're doing. See, if you're using fold left and fold right, then that implementation, so the fold right is already available to you as a tool, and in your usage you would pass in a thing. So here's an example. Okay, here's a version of that, which I'm calling fold left fancy. Let's look at the explicit syntax. Okay, in one call fold left, I have a function here. It takes in a sum double, and the next double coming out the list, and I add it together to the right side of the arrow. The second call, the fold left, this is kind of tricky. I'm actually not doing anything with the next value. I don't really care what its value is, I just need to add one.
That was the structure of the data.
I don't actually need this value. Exactly, it was, but I'm not actually using the value for anything. All you need to know is that it exists. So that's another common pattern to see. Yeah, so. Yeah.
You want to do this with one sheet.
Yes, exactly.
So inside here, it's supposed to be function.
That would be, I think you've been thrown off by being on more than one line, which is my fault. This is the Z, and then in here, because I intended for this to be kind of complicated, you can pass in a parameter like that. So this is the first group of value parameters, and this is the second group. And feel free to do it on one line if you choose to. And the other thing that's thrown off about this is that this is a, okay, even though there's parentheses, or those parentheses belong to the tuple, not because it's brand.
You want to code something here that had all of that.
Yes, you are. Yeah. So you're going to, in one action, you are going to sum a count. Yes, but before you bother to implement that, come up with a type signature of the anonymous function. So you're going to define an anonymous function just like a, here's an anonymous function. Hey, thanks. So come use this. To the left-hand side of the arrow is like the input types to the anonymous function. Right. So don't even worry about the right-hand side right now. Just come up with what is in this side for this example, and get back to it. Cool. And also, if you want to jump, but before you get to the right-hand side of the arrow, then supply a value to z. Yeah. First thing up, ask yourself what A and B are, and come up with the first half of the anonymous. Yeah. Cool. Hey. Okay. Okay, so first of all, good, you got the case again, which is good. And you're returning it something. You're right, because the function is, it takes a B and an A and it returns a B. Yeah, so good. Okay, so okay, so what is there a compilation implementation?
Well, if I just run it, I can't
No, that would be if it were like pattern matching or something, but it's not. So
so that is actually
average 2.
Yeah. So you're already operating.
Can you just copy and paste from def average 2? Copy and paste in there. Great. Yeah, I do want to do enter paste mode, so do colon paste. Okay, now very good. And then control D.
Yeah, some of that's going to tell you.
Good. I know that's blue. If you're importing the object and there's a dependency component, so you look through here, and if I put like a call, like it's calling something, then you should comment that out. Yeah. So thank you.
Yeah, it's like the
This hurts so bad.
Okay. That's okay. That's okay.
Okay.
So
When I'm going through this list, am I getting an AM or am I getting a list at
You're getting an item, just an item, not a tail list. Nope. So, yeah. And the rationale for that is that you would be concerned that if you were implementing full left or full right, but you're not, you're just using it. Okay. Yeah.
So given that.
Thank you.
All right, so getting to the last one, I have some.
Did you see the hints in the readme?
I bet you did. So every time. Oh, it's easy. I just always have to accept the current, and then when I need to produce the current every time.
Yeah. Right. Yeah, it's just going to override it.
Now it's actually, I'm still got my.
That's right. Well, that one's harder.
So how do I say this? Like the back the item. So I don't have anything like item in there. As in, like how do I access the item that this is?
Let's see. Okay, in this example, you permitted the throw that exception. Okay. Yeah, that's an unsafe way of getting the first element, and it's going to crash. So it's There is no first element. But that's okay. And I put that in the README that you're permitted to throw runtime exception.
Yeah, because that's the way it was access it. I guess that's the one part of that. When I was here, oh, no. Underscore is just that. Yeah.
Let's see.
Right, so in this thing.
You're right. Okay, so you're right. What the goof in this exercise is that you're going to see one element twice, which is the head of the whole list. But it doesn't end up mattering. Oh, that's okay. No, you got to the right part. Okay.
So the full left, this is actually parsing.
Whoa, okay, wait. Is this an appropriate way to access like the head? I guess like so
you would call it as a method on this, just like you've done here. So fold left is a method on this. Head is a method on this.
call it yours. Am I automatically just getting the head? That's what I'm
No. Oh, okay. You would get the head in here, but you would get the next element on this function.
This is a type list right now.
Let's see.
Or is that specific? Is that A? Yes. That is.
Well, let's look at the type of signature fold of the method fold left, and here. Oh, that's a good one. Super. Okay. Okay. So now keep in mind the list is way up here. So we have a list of A's.
Okay. Yeah.
And all these things are defined inside of this class.
Yeah.
An instance of this class. None of these are useless. None of these exist until you build the list. So the ones that exist, regardless of that, not quite. These are like static. So that's subject for okay. So yeah, let's see. Okay, that's okay. Oh boy, this sticker. This people don't know this hidden. It is a hidden. Sure. Okay. Okay. So this is whatever starting value you want, and I suggest using the head of the list.
So do I have to? Okay, so I'm not given the head of the list. So here I have I'm actually typing this.
Yep. And it's unsafe.
Why am I the thing I don't understand with the iteration across fold left?
Sure.
Why am I not? Why is this here and it's not just the value of this? Because I thought it was already like the value.
It will be. You'll see it again. You're going to see this head twice. You're going to see it twice. Okay. And two things. Okay. It's unsafe for two reasons. For one, you call this dot head. And for two, we're not supposed to be folding across.
Into the final.
Maybe that's that's the only reason why it's unsafe. Okay. Oh, it's also unsafe because it's just counterintuitive to return the last element.
Right.
Okay. So two reasons why it's bad, but that's okay. Yeah. So now, you know what A and B are? A is A. Oh, B is A. B is A. Yeah, you get that. Well, actually, if you're referring to the starting value, I wouldn't call it A. I would call it whatever letter they give you. Z. Z is the head.
So what?
Okay, is the head. Okay, so then I now need some operation that just ditches.
Yeah, I would. No.
Right.
Well, the goof in this example here. Let's copy this. Yeah, just paste it right above there. Just do a comment and paste. Yeah. It's okay. That's okay. Yeah, you are close. Great. Okay. So, okay, for the sake of this example, it's actually okay because if the head and the first thing you come in here are the same value, it's like the same answer.
So
this one is going to replace this one.
Just
like this. This is all it needs because it knows you start with this, and then you just progressively apply.
How do you not see this?
Okay. Well, this one is not. It's not a parameter for the anonymous function. Okay, so we know that you got it right here. You're declaring two arguments for the anonymous function.
Right.
Okay. So this is a value.
You're right.
Okay.
So that means this.
Let's see. Not quite. This is still a value here. So you're going to make up two new variable names. can call it whatever you want. They've never existed before. That's okay. That's fine. That's it. Not quite. This is. Let's do. Show me the rebel. Let's do an anonymous function. No concern with full left or full right at all. We're going to declare an anonymous function. So open print. We'll call it foo. And colon. And it's going to take in a double. And it's only going to take one argument. So close print. Now do an arrow. And foo dot to as in to int, int. Great. Okay, you've created an anonymous function.
Yeah.
Its input type is double and its output type.
Yeah.
Okay, so this is only different than this one because that one takes in 2 arguments. And this one takes in. So you're going to create an anonymous function just like you've done.
Okay.
So you got one more paren there. You're going to declare. So tell me this auto completion that's like, yeah. It's okay. It's just adding parens in the wrong place. So this is useful. We're going to put in that, and that's like a filler. Okay.
And I know what this is, right? This is just whatever that. Just kind of. It should always be this.
That would be the head of the list, but I want the tail of the list. I want the very last. Not quite. No. This Z value is only used once. It's only used in the very beginning. I think that maybe that's the crux of it. Yeah. Because I think what you're thinking is the implementation full left.
Yeah.
Which is more complicated, and you do see Z more than one time.
Okay.
But this is just the use case.
Okay.
Yeah. So tell me, I'm going to give you the variable names. I'm just going to, they have no significance. It's just A and B, and I'm going to ask you to tell me what the types are. So in an anonymous function, it can be colon. So you figure out what should come after the colon here, and then only then do the implementation.
Okay.
Cool.
Okay.
I think those variable names are misleading. It should be.
It's flipped.
It should be. Yeah. It should be A. yeah. I just picked A and B. Thanks, Jake. Thanks, sure. Yeah. Great. Good. Yeah. No, this is different. This is different. Not necessarily. Oh, okay. Well, no. Where's your text over?
Oh, yeah, the text editor is right.
Very good. Okay. Good.
You know what I was wondering? I got to the concert. Somehow, like,
Here, hold on one second. I'm going to do something totally different. I'm just going to open up a new project. Okay, we're going to go into, and then you're going to get all the benefits of IntelliJ. So it's going to resemble what you've done before. Where did you put Scala class? Yeah, we found it somewhere here. Carl, it's right there. Why is it not?
maybe it's not very open. Then open?
That's a good guess. It should. Oh, here it is. These are the fine icons. So I didn't recognize it. Okay. Auto import. No, let's not do that. Drop it out. Sources. Okay. Okay, now. It will, yeah, it will, and you're going to get all the benefits of intelligence. So,
but now they maybe really see that is what was going on in the steps of the process.
yeah.
I didn't, I swear.
Yeah, hold on just one second. Okay, we don't want these. One second. These are just artifacts. We don't want these. Okay, so the ones you're interested in are great. So I'm going to go over here, Scala class. We're going to go into tutorial. Source name. The
Section 2. There you go. Yes, you can. Well, you should, okay, can you open up the terminal? Okay, very good. Okay, now go into SBT. Great. Now you're going to do the project tutorial, and then do console, and then import, and then do an import on this object here, object folder. But it's not import folder directly. It's import com.datascience.education folder. Dot underscore. Yeah. No, this is misleading. That's out of date. Yeah, thanks. Let's go here. Okay, go into the tutorial project, please. Oh no, just in SPT. I'm sorry. Type in project. Space. Tutorial. Okay, very good. Cool. I'll get back to you. Thanks. Hey Harry. How's it going? Contains? Gotcha. I see. No, that's okay. I think your syntax is just off. You wouldn't have to construct a boolean like this, and we can confirm that with the. I think they're just available. Okay, so simplify that. So get rid of that, and then double check. It isn't a single. I think it has to be double. So try type in false, and then and true. Let's see if it works with the single and. It might work, but I think the single and actually refers to some sort of a binary. It works. Okay, either way.
So actually, when I did that
Okay.
here, I think it said to me that I found
Found boolean. Okay. Now I see what it is. Okay, so basically I think you've gotten confused between the A and the B types. Now, show me the Scala. There's a link in the getter for the Scala standard library list, please. Yes, please. Okay, so do you have the README open as well? Okay, so let me show you the difference between these two implementations. In this implementation of fold right, we have to pass in the list today as an argument. Okay, in the fold right and the fold left defined in the Scala standard library, this is going to exist inside the list. So we do list.fold right. And in this one we do fold right and we pass in the list. Okay, because of that, in this version we declare both generic types right here. Okay, in the list in Scala standard library, you only have one generic, and then the A is created way up here when you create the class. So if I create a list, I do new list, I'm going to pass in, or it's going to refer to list of doubles or list of squares or something like that. So that's where the A comes from. So I think the mistake is that you've passed in the wrong type here. As the thing is, you're not. Let's see. This is going to be the output type. I think you were thinking of this as the input, the type of the list that you're folding over. And the reason for that is that if you look at fold here, this is the B type, and that is the output type of this function, rather than the input type of this. Exactly. Yeah. And so its complaint was found Boolean expected A. The only thing that was wrong. Exactly. Yeah. And now it's going to find the Boolean and it's going to expect the Boolean. So yeah. So I think you're right. We can do Control E. We'll skip to the end. Yeah. Control D.
It can't be the same.
Okay.
So you can turn this event into one sample.
That's fine. So you're going to construct a list. So just do list and 1, 2, 3. Sure. Absolutely. It could be any type of generic on it. Yeah. And then pass in a 2. The items. Okay. Not quite working. Where? False. Okay, so you have booleans. The condition is wrong here. Okay, so either the current item is equal to what you're searching for. What is the relationship between like the history? It's yeah, I got you. Cool. Thanks, Harry. How's it going? Cool. Oh, why would we use one over the other in general, or? Okay. This is in the primitive implementation of full right. So think of it this way. It's kind of like, it can't just be turtles all the way down. It has to be implemented somewhere, you know, with basic Scala operations. So I can't just implement it. Full right is a recursive function of itself, but it's always going to exit the recursion right there. And whether you're looking at implementations of the monad combinators, where they're all like stacked on top of each other. It's like you have dozens of combinators in the monad, right? And they all come back to unit and flat map. Well, then somewhere it's going to exit, and unit and flat map are going to be primitive. They're not going to be implemented in terms of the complicated combinators. So that, I think that's the answer to your question. It can't be turtles all the way down. Different combinators stacked on top of each other. Does that help you? This is like a you know, for all its complexity of fold right and all the other things that are built on top of fold right, it's just simple pattern matching at the bottom. So. Sure. Not in daily use, I would say, because most of these, there's lots of helpful methods here that are implemented on top of this. But these two are introductory combinators that will precede other combinators that we'll get to later in the class. So it's true that at first glance, you would think that, you know, index of and head option and roots would be much more useful, but we're going to teach you these complicated combinators that don't immediately have a use case, so you'll find that they're very complicated. So they're much more powerful than index of and index of slices. You know, there's like a continuum here of like what people are familiar with, and then we get more and more abstract, but more power. so. It is a linked list. Yeah, there's an array type. List is the cons in the nil thing is useful for lots of these demonstrations. For performance, you would often use an array or something. But yes, yeah, it is, or a vector. Those are not linked lists. But we're not going after performance immediately. We are going after purity and reliability. And yeah, I mean, you wouldn't want to use a list to store your mutable user base, but you shouldn't be using a mutable array even if it's fast in the first place. So you're going to use something completely different than what we're familiar with in Python or something, where you're just mutating array and we're replacing elements and chopping things out and inserting things. So despite its appearance of being slow, the data structures and the patterns you're going to see later will go over that. Yeah. So, even though it's a linked list. Thanks for asking. I hope that was helpful. Hey, what's going with you? Super.
What's coming into here is people.
Factorial.
First thing.
Oh, these are the future.
Yeah. So like
What tutorial is this? I forget. Factorial. Factorial 3? Gotcha. Cool. Do you like my readmes?
yeah, actually, I mean,
Thank you.
the problem is, well, this is
Sure, yeah. Well, I slave over every choice of word in this. Not really. Cool. Cool, thanks. Well, I'll tell you, I mean, like, I learned this stuff much more slowly than they did over the summer. So the idea is impression. So that's okay. Your point is actually, put all these edge cases in your face. Yeah, sure. Yeah. It's just like, some of these things are so foreign to me. It took me so long to find an answer of why these case statements were showing up in random places.
Yeah, that is something to this day. I was last week. What is this? Well, what's weird is there's really weird uses. Like you can use case statements for partially applied functions. No, it's partial functions. There's places where case statements can use generate partial functions.
Sure.
And afterwards, just doing case statements by patterns. No, it's not a partially.
Something else. It's a second use case. Yeah. But often you'll just see it before you're heard of the partial function. Case mixed in there. But I thought it was supposed to be an anonymous function where this case comes from. It turns out it's different types of statement. So see, the case statement is a subtype of the anonymous function from A to B. So you can put that in anywhere. Yeah. So that's why the substitution. I should point that out to everybody. Thanks, Brandon. Right. That's unsafe too if you don't have it. No, actually, it's not. Let's see. I think it'll always return if you only have one element, like call tail. It's just going to be nil.
Okay.
Yeah. So I think it's safe.
I'll worry about it.
Yeah.
Case is just the second element.
Right, so I have 1 and 2.
Yep.
I'm going through 1 and 2.
Yeah.
My Z, which means my D type.
Yeah.
Which means I need element 1 of this thing. So I know I need that.
Yeah.
So I should end up with last element.
Yeah. It's kind of like you have these two packages, and you're going to throw them down an elevator shaft. They're stacked on top of each other. So the lower one is separate. Wait a second. X. This X?
Maybe this is bad naming parameters, but it helps.
Well, let's see.
So Z
X,
is this thing.
X is going to be.
Type is going to equal this type here, of whatever the type of the list is. It's going to equal my A. Is that correct?
Let's see. Okay, well, this is the B and this is the A.
Right.
Okay, so what's the type of the B? Exactly.
The type of the A A is the A, right?
Yeah, that's right. Yeah. So annotate that for me. Okay, there's two ways. You can do it either. Not quite. The syntactic sugar one is up here. But what this really is, and you can look it up in the Scholastic library, you type in tuple 2. Yep, there it is. Tuple 2. So you do a tuple 2 of an A and B or something. So try it this way explicitly, please, just for fun. Well,
so I type in tuple 2.
it is a type. It is a. Let's see.
The local instantiated type.
Hold on a second. There's a better. This is confusing because it's a class. But what we're really looking for is. We're going to look up. Okay, so here's your functions. These are what they actually are under the hood. Okay, product. Yeah, I'm looking for. Well, what it's exploiting here is that a case class. A class is also a type. Not every type is a class, but you think of it too. No, a class is a type. No, you could do because you can take it a class and give me something of the type class. Yeah. Well, specifically, this number is every one of these is different, so they have a different number of parameters, the type parameters. This is the tuple number, so that's what they're. Yeah, but it's sort of not medically. It's the tuple 2 is at the bottom. Okay, so first of all, we're going to explicitly pass in the type parameters for clarity. But you could do it with tuple 2. And now this is a type constructor, so you don't get to use this until you specify. This one only has 2, so you have to specify that.
Okay.
So specify.
What do I have to specify in here?
Exactly.
What are my type
That is correct.
The elements?
That is correct, yeah. All right. Okay, now you can copy that over. Now this is incomplete because you can't just use it. Yeah, exactly.
But then this is just a single A.
That is correct.
Okay.
Yep.
I am not quite, I know I need the document. I'm not 100% quite yet. Oh wait, this is going to map down to, okay wait, so as I'm moving through this I have 1, 2, and at the end of the thing, wait, what happens when I get to the end of the list? Do I end up in the middle end of the thing? Or does it stop before that? So I'll end up.
It's going to stop at the end. Yeah. Yep. But that's what you want. You want penultimate in -1.
Right.
So.
I need.
It's more about the object is
and then it gets that just comes with it. But and then I just want the first thing of that.
Yep. I think that's right. I think you got it.
Well, it matches the type, matches on position, as long as the position is that.
I should ask you this. Is there a better way to like input it, a script, so that I can?
There's not a slick way. And then you can just paste it on the best way. When you get it. Yeah. Okay, that's gonna come later. No, let's see. Later, you're gonna see we're gonna get away from doing so much in the REPL. It's gonna be like a runnable method that compiles, or an object that compiles and tests or something. So we're very quickly going to abandon that. Yeah, so there's no easy way. The closest thing to it is called. So I think maybe you got it in reverse. Maybe you should be using. It's giving you.
That's one. When they put it come in, it's just a unknown tuple.
See if it's carrying along the head. So you got one thing backwards. That's not, it's not, this is not always it. So this, but you could consider to make it always the name if this is the wrong function.
How to change it, but I don't conceptually understand why.
Okay. Well, draw it. I would draw it. So, that's okay. Let me get,
It's impressive to see this better than what we should draw, because I do not understand why I think this is right.
that's fine. I'll be back. You seen the movie The Naked Gun? Have you seen that? Oh, okay. I was gonna make a joke about the PA system.
Okay, it worked.
Here, I'll be right back.
Case.
Okay. So. Well, no, that makes perfect sense. I think about it. I gotta think about this. Okay,
So here's your two.
What is your index? No, oh, it's always like x n plus 1 equals x whatever. Nope. Plus. Okay, that's okay.
Let's see. So your list is 1, 2, 3, 4, 5, and this is the one you want, right?
Yeah.
Okay, so this is your final tuple.
Yeah.
Right, so this is 4.
Isn't that item 1?
Well, what you ended up with is somehow you were carrying the style. So you ended up with 1, 2, 3, 4, like that, and then you had this. You had
The final time is
so you had 1, 2, 3, 4, 5. This is 1, 1, 1. This was your final tuple. So you ended up with that. So this is how you could pass the head along.
Wait, hold on. There's actually a reason you're confused, I think. In the previous
Yeah,
definitely. There's one more step to this problem.
Well, no, it works. I just don't know why it works.
Well, it's because you received the 1, right?
Okay, well, but here, if I change this back. To 1. And I go. All right.
No, but wait.
I broke it. Right. This is not going to work.
Wait, but no.
Hang on.
Hold on. Can you expand your spawn text a little bit?
Yeah.
I think you're like missing part of your.
Okay, so this is the confusion. Why is this?
So look at that final tuple, right? So that's getting returned, and then you're taking the first element of that returned tuple.
I'm sorry. Say that again.
So wait, so this is all getting returned, right? So this at the final fold left puts this. What was the second element?
It's this. Oh, the second element. Oh, it's flipped.
You're pulling
This,
that.
this,
Yes.
oh, so this always comes down. So this is like this, and then if I'm looking at the big parentheses, I continue, and then this goes in.
This would be.
I should print this, so this should be. Wait. 1, 2, 3, 4, right? In my last one, so then I end up with a tuple of this, and then this element, and this, and all of this is tuple, right? Ignore them. So this is just them how I walk through, right?
Well,
so this is the last. This thing here is the last thing I end up with.
But that was the mistake version, right? So you want to end up with a tuple of 4 and 5, and then take the first 4, and you ended up with a tuple of 1 and 5. I mean, imagine if I have a full left, and it always passes along. So I have a list of A, B, C, D, E, F, and it's supposed to look at every pair of these elements, right?
Yeah.
And then let's say I pass it the wrong function, see, oh, pass along the first one. So A comes up here, pass along the first one. You know, I could ignore all these things even and end up with, that's how you, this is like the opposite. No, you got it right. I'm just saying, this is what, the first one you had was the opposite function. This is like use fold right and fold left to get the first element. You can do it. You can do it, yeah.
Oh,
So-
you're right, because I'm misunderstanding what this tuple is that's coming through on this side.
Well, you
That's
were,
why, and I kept passing the one.
exactly,
So,
exactly, yeah. So you were carrying along. Let's implement this.
I thought,
Check this out. Okay, so if I have a list of A, B, C, D, E, okay, I'm going to write a full left program. Just return the first element. Okay, so I'm going to call this L equals, okay, L dot fold. In fact, let me scratch this. List B, C, D, E, F. Okay. Fold left. Starting value is going to be A. No duplication like this here. Okay. Anonymous functions types are going to be Y and X. Okay.
wait, why would it be Y and A?
I just make it. I just trying to avoid. Okay. So. Okay, this is the B type, this is the A type. So
that's that, right? This is the, oh no, this is the B type, it's supposed to be here, so that is that.
yeah. Okay, so what do you think this program is going to do? It's totally useless. Well, except for trivial. Not quite. It's the opposite of that.
It's just his head. This is where I'm confused. It's coming backwards.
Yeah.
So then we'll just continue to turn B.
Not quite. Not quite. What comes before B?
Oh, the empty.
Yeah, the A is right there. So you kind of ended up with a version of this because you were passing along that first element way beyond where you were supposed to.
Okay.
Yeah. So,
Okay, I sort of get it. Okay.
so your mistake was not that similar from this program.
Okay, can we
Say it.
Yeah, can you do a new page?
Sure.
I'm not sure I'm fully grasping. I want to try and
Sure.
figure out what.
Sure. Yeah.
All right, so A, B, C, D. Let's do a short one.
Cool.
As I'm going through this, I just want to look at this first tuple. Or actually, can we look at the value of the anonymous functions at each time?
Sure.
I think the output on each side should be what is Z and what is X explicitly stated.
Wonderful. Yeah. In fact, you could do that with a side effect. You could put a print statement right in there, so you don't have to do this on paper. Okay. So first of all, our anonymous function is going to grow a little bit, so we're going to put some parens here.
Okay.
And here. And let's.
It auto-filtered.
Oh, whoops.
Okay, so this should be like this.
Yeah. There we go. Yeah. Now let's give ourselves some more space under the place that curly brace to symbolize that it takes more than one line. Well, that's not always the case. There's weird edge cases there. Okay.
I just moved the other one. Yeah.
Great. Okay, then this goes down there. Okay, so now you can do whatever you want. You can put a side effect.
Okay.
Prints. Yeah, great.
So what I should do is print. Since I've bound these to names, I can access something in there.
Well, let's see. The comma in the print line is not valid syntax. So here's how you do string formatting in Scala. You do quote. Yeah, and then do a $sign, and that's how you bring in a symbol inside of the string. Now, delete that comma, and do a few spaces in between. Great, and do a $sign. And then close the quote after X. Okay, and now you're going to put an explanation of what these are. You're going to call it, because the Z is going to be replaced with a value. So,
This is how it is.
exactly, with a $sign. and also that S before the string that begins. Very important. So we're going to call that 2, and we're going to call this sure, we call it A. Okay, and then you can run that.
Yeah, I think the thing I got the right answer right. It's conceptually understand why.
That's fine, but it's extra confusing because this is full left, so it's actually going backwards. So, there you go. Right. Okay, it's moved. There you go.
One and what? This is not
One, two, 2, 1.
okay. So like,
You know, we should try a longer list because maybe there will be another 5, 6, 7, 8.
You initialized.
1, 2, 2, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7.
I don't understand why it's doing that again.
Yeah.
Okay, so I expected this.
Yeah, I expected that too.
It's still false. It's true. It's true. We'll also keep going.
Baby.
Well, okay, so this is moving along how I expected it to.
Okay, well, we know that we have a goofy starting value, as you've seen this head twice. It would be more intuitive if these were flipped in order. Probably. So these first, let's see. This is your Z value here, and then I'm pulling out and I'm chopping that off. So 1, 2, 1.
Starting with this pair, right, and then in my function, I'm saying get the second one and then put it, right, pass that way.
Yeah. Well, it's replacing. Okay, so these two are straight out Z.
This one's 1, right? So then this new Z is going to be the 2 and the 1. So that's that 2 and that 1.
Yep. Yeah, exactly. This 2 survives.
And that 1, so that's a 1, 2, 3. So then I have 3, 4, 5. Now this pattern happens here.
Yeah.
It's just this pattern here.
So let's do a version of this that's just for numbers. And then what the benefit of that is with the sentinel values here instead of this list.head.
So that you just want to put in.
It's just going to be int exactly, no generics. Okay, so get rid of the A and then replace it with this. That doesn't have to be anything because that would be declaring a generic. You don't need to do that. So, exactly. Yeah, and replace the A with int. Yep, great.
This is going to return.
Exactly. And give it a second to call it an alternate. A camel case, yeah. Great. Exactly, yeah, there's no A. That's absolutely correct. Yep.
And that A has to be.
Yep. And no, that's great. That's great. That's fine. Okay, now the benefit of this is that we're going to use sentinel values. So let's make the negative. Let's make this one 888, and this one will be 999. And then it'll be more.
Okay, yeah. I think this is going to more demonstrate show the pattern that we identified before. Yeah.
Cool. Yeah. Call it ultimate.
And then let's do it on the longer.
Sure, yeah. Okay.
Okay, yeah, so I have my default values to begin with, right? And then the first thing here.
Exactly.
Picking that up, and it's grabbing the second thing from that one.
Yep.
Combines them, and then the pattern begins.
Exactly, and I think it'll throw a runtime if you give it a list that has fewer than one element. No? Gotcha. Okay, you're right. Yeah. Yep. Cool. You know what? The reason I said it will throw a runtime if you pass it in an empty list, or a list that has fewer than 2 elements, then lists of tail.head. So try to list, well, we don't have to do this.
That was a very confusing iteration. Okay, so this conceptually is an important point for me because that means we're always starting with these default values.
Exactly.
Across this defined.
And I think a little earlier you were kind of confused between, you thought that we were looking at the Z over and over again, and you were thinking in terms of the implementation of full right and full right, because that is true for that. But this is just at the usage level.
Okay.
So most of the time, you're going to implement these combinations of exercises, but most of the time.
Is it weird that I find this more intuitive than the first two classes that I watched?
No, it's perfectly weird. It's not weird at all. It's perfectly good. And this was originally one of the early lectures on the swap order.
Okay. I was almost thinking about like giving up. So like, no, I'll go to the next one.
I'm so glad you're still coming. And this one was supposed to be easier, it wasn't easier. It was purely like so. The fold left and fold right, basically they're meant to symbolize these combinators that we're going to see more powerful combinators. And you're going to find fold left and fold right. It's part of the big family. No worries. Thank you, Jake. Okay, keep the paper, yeah. Thanks. I'm not sure. Probably not. But cool. Thank you, Jake, for all the questions.
Yeah, this is very helpful.
Cool. Hey, yeah.
Full drive is not tailored recursive. It's not like recursive optimized. Why would we need it?
Okay. Yes, that's the short answer. Yeah, for streams, because you're not going to be able to reverse a stream. Now, if you want to tail recursive stream, you're going to get into stream transducers, Scala Z stream. Functional stream through Scala FS2, which comes after just the streams that Scala standard. Yeah, so.
And streams is just a list. They had evaluated, right? But for the tail, it has a function that evaluates.
Yes. Yeah, that's a lazy list, a stream. But there's a more complicated stream, which will come much later.
But you know that the Pascal, even list side, placed.
Yes.
So they don't have just like full right. Because for them it's only full left.
I believe so, yeah. And because of its laziness, it would seem to be tail recursive. I'm not sure, but it's not actually. Okay, my feeling about that was that it doesn't blow up the stack simply because you're not pulling things out of the list without passing.
So Scala runs on JVM. They said that
it's eager almost all the time. Without making an exception, it's eager. Now, you also saw an exception here, where all those things that were in the object folding were lazily evaluated, right? Because it would have been intuitive to see how that happened. So there's laziness mixed in there, random places. Thanks for asking.
That looks a little bit better.
Have a good one, Jake.
Yeah, thanks. I'll put the sandwiches away when they're done.
The what things?
The sandwiches away.
Oh, thank you. Thank you.
Thanks for the lecture, James.
Yeah. Okay. You're welcome. Thanks.
Maybe I'll talk this stuff
So, I didn't.
There's a video on YouTube and the tutorials there. Rough. I think it's about 12 weeks. Yeah. Are you on the Getter channel?
No, you can call it
Oh, I got it wrong. It's longer. Okay. Yeah. But look at the Getter channel. Have you seen the Getter channel? It's right here. Yeah. So look at Scala class, and then there should be a link. You go to the home page, and there's a little link here to Getter. Yeah. And we put the videos on there. There's also a forum here, and Janie puts her updates on what to read in here.
It's that they've got people on the team that can do what I already do.
Thank you. See ya.
They don't have like the holistic view of that. They don't necessarily need it. They just need options. Thank you.
Absolutely. Yeah. Thank you for coming.
Thanks a lot.
Good. Have a good one.